Okay, so for this standard, we have talked about some of these things in the past, but the first thing is a function. We've talked about what a function is. A function is when every x value is mapped to exactly one y value. Now we're going to be determining whether things from a graph are functions. So remember, or hopefully you can recall, that we use the vertical line test to determine if our graph is a function. And I'll show you what that is if you don't remember. There are different types of functions. We did not talk about this part yet, but a discrete function or a continuous function. Now, a discrete graph is a graph that is disconnected or a series of isolated points. So for example, if I had an x and a y axis and I had a graph that looked like this, that would be discrete because it's just a set of isolated points, which when we get to statistics, we will see more discrete graphs. What we've been dealing with are continuous graphs. Continuous graphs are when you have a graph that has no break in the graph and that points are connected with a line or a curve. So for example, if you had this coordinate plane and you had just a straight line going through a set of points, that would be a continuous graph. All right, and that's what we have been dealing with so far this year. Now again, we're not going to see discrete graphs until we get to statistics, where we'll look at some scatter plots. So now we have talked about domain and range. Domain is the set of all your x values, and range is the set of all your y values that are involved in your function. Now we write domain and range in set notation. Remember that if we have a number that's not included in our domain, then we use parentheses. And we also use parentheses when we use negative infinity or infinity. And then we use these brackets when the number is included. In our domain or range. So that's what I mean by set notation. We're going to use, remember, the parentheses or the brackets to determine what domain and range is, and we'll review that when we go through the problems. All right, so intervals of increasing or decreasing. This is, sorry. All right. So actually, let me change this. All right, so intervals of increasing is when your y values are going up. Intervals of decreasing are when your y values are going down. And what we are really focused on, because we're going to write this in set notation as well, we're going to write this in set notation. But we are only going to write the x intervals of when the y values are increasing or decreasing. And then same with intervals of positive or negative. This is the portion of the graph where the y values are positive or negative. And we write this also in set notation, and we're only going to be writing the x values within our intervals, within our set notation. All right, maximums. There's two types of maximums. There's something called an absolute maximum. That is the absolute highest point on your graph. And then there's something called a relative maximum, which is actually a highest point in a particular section of the graph. And then same with minimums. There's two types. Absolute minimum is the complete lowest point on your graph, whereas a relative minimum is the lowest point in a particular section of the graph. And then end behavior is something that we'll be talking about. The end behavior of a function describes the behavior of the graph of the function at the ends of the x-axis. And I'll specify more about that when we get into our examples. But let's get started with some examples here. So Remember, if we're determining if something is a function or not, we use the vertical line test. And so with the vertical line test, which I'm going to make this a little bit thinner, what we do is we drag a vertical line across the graph, and if it hits 2 points at one time, then it would fail the vertical line test, meaning it would not be a function. But in number 1, it actually passed the vertical line test, so number 1 is a function. So I'm going to circle that there's a function. X-intercepts are where your graph crosses the x-axis. Do we have an x-intercept on this parabola? Yes, we do. So I'm going to circle yes, and then it says the location, and I write the ordered pair of what the x-intercept is. It's the ordered pair 0, 0. And then y-intercepts, where it crosses the y-axis, well, this parabola also crosses the y-axis at a point, so it does have y-intercepts, and that location is also the point 0, 0. All right. Absolute minimum. This means the very lowest point on your graph. Do we have an absolute minimum? Yes, we do. The graph's lowest point is this point here, so I'm going to circle yes, and that is the point 0, 0. Absolute maximum. Now, we do not have an absolute maximum because this graph continues to go up and up and up forever and ever and ever. So I'm going to select no. There is no absolute maximum, and I'm not going to write anything on the line here. You can leave it blank or you can cross it off. It's up to you. Now, a relative minimum is just any low point on your graph, which, again, we have this low point here, which is the point 0, 0. So yes, and then we write 0, 0. And now, just because your graph doesn't have an absolute maximum does not mean it doesn't have a relative maximum. However, in this one, there is no high point on the graph, so there is no relative maximum. And we'll see an example of where you do have relative maximums. All right, so domain, I'm going to remind you, if you have arrows on both ends of your graph, that means that eventually this graph's going to spread out along the entire x-axis. The domain, we're looking for the leftmost point and the rightmost point, which in this case, the leftmost point is going to be negative infinity. The rightmost point is going to be infinity because this graph's going to continue to get wider and wider and wider. We write this in set notation, and when we write it in set notation, if we're using the negative infinity and the infinity, we use parentheses. We don't use those brackets. Okay, so now intervals of increasing. What we do with this is we start at the left side of my graph. And what we do is we draw the shape of the graph, and what's happening to my y values right now is they're going down. So from the x value of negative infinity to the x value of 0, my y values were going down. But from the x value of 0, and now my y values are going up, to the x value of infinity, my y values are going to increase. We're going to write this in set notation. My x intervals of increasing, when my y values are increasing, my y values started to increase at the x value of 0, and they continued to increase to infinity. Now, when you're doing intervals of increasing or decreasing, you should never have brackets, because at the point that the x value of 0, my y values are neither increasing or decreasing. So we do not want to include that point because the x value of 0 is when my graph was at the lowest point. So it's neither increasing or decreasing at that point. Now, intervals of decreasing, my y values started to decrease at negative infinity, and they continued to decrease up until the x value of 0. So you always start with your lowest x value and then go to your highest x value. All right, the range. What we're looking for is the lowest point and the highest point. The lowest point on my graph is 0, and my graph is including 0 in my range. And the y value, the highest y value, it keeps going up forever and ever and ever, so it keeps extending all the way to infinity. And then we close out with a parentheses, because whenever you use the symbol of infinity, you should always close off with a parentheses. All right. Now we're doing the intervals where the y values are positive. So we want to state the x values of where the y values are positive. Well, the y values are always positive. This graph never dips below into the negative y value range. So the intervals of where my y values are positive, x, it starts at when x is negative infinity, and it goes all the way to when x is positive infinity. And then the intervals where the y values are negative, well, there is none. All right. And then lastly, end behavior. So what I mean when I'm talking about end behavior is when my x values start trending towards the negative infinity, what's happening to my y values? My y values are extending up to infinity. So as x trends towards negative infinity, y trends towards infinity. And now as x trends towards infinity, my y values are going up and up and up, so my y values are also trending towards infinity. So as x trends towards infinity, y also trends towards infinity. And then the last question that we need to answer is, does this graph have symmetry? And yes, it does have symmetry, meaning that if I fold this graph in half, one half lies on top of the other. And the axis of symmetry is your y-axis. So this does have symmetry, and the axis of symmetry is your y-axis. All right. So that is our first example. We will need to continue the rest of our examples in another video. So please move on to the next video to do our next examples.